So this tutorial is about to create a decoder with three inputs. So first of all, we need to find out how many outputs are we going to have. And the formula is 2 to the n is equal to our outputs, where n is our input. So in this case, if we want to create n is equal to 3, so if we want to create a decoder with three inputs, that means it's 2 to the 3, and 2 to the 3 basically is 8. So a decoder is going to have three inputs and 8 outputs. So how does it look? A regular decoder has 1 and 2, and then it has 1, 2, 3, and 4 outputs. 1, 2, and 3. So that's input A, input B, and then also has an enabler, which could be on or off. So if we want to create an enabler that has a decoder that has 8 outputs, so basically what we do is we have 1, 2, 3, and 4 outputs. Six, 0, 7. So here we have our input 10. Let's say this is an input 10, input 11, and then we have an enabler, which we're gonna call it enabler 1. So A is gonna be our input 10, then this is gonna be B, and we're gonna call our enabler 1 is gonna be C. So then we're gonna go here and we're gonna put this is gonna be our enabler 20, input 20, input 21, our enabler 2. So basically we're gonna connect A to the first input, we're gonna connect B second input, and we're gonna connect C, which is our enabler 1, to our enabler 2. So our enabler could be either on or off. So in this case, now we're gonna make how it looks inside. So in order to do that, we're gonna put this is gonna be A, this is gonna be B, and this is gonna be C. So we're gonna make big line all the way to the bottom, and then we're gonna make a big line also for B, and a big line also for A. Then we're gonna do this. So basically A could be 1 or 0. B is the same thing. B could be either 1 or 0, and the 0 is represented for the inverter. And then we're gonna have C, which could also can be 1 or 0. Make this big line over here, and then we're gonna have our 8 outputs over here, which we're gonna use the AND gates, 3 and 4, and that's for the first, and 1, 2, 3, and 4 for the second decoder. So in this case, the enabler could be either on or off. So whenever the enabler, which is C, is on, we'll go connected to here. Three, and 4. So we're gonna have our outputs where the enabler is on, and then we're gonna have 4 where our enabler is off. So then it's the same thing with A. So A could be either on or off. So we're gonna have A on, we're gonna have 2 A's on, 2 A's off, 2 A's off, and then on again 2 more, because remember this is the second decoder. So A is on 2 and A is off 2. So in this case, we're gonna have B, which is the only one that is not connected in this case. And as in the truth table, B could be when A is on, B could be either on or off. When A is off, B could be either on or off. Then we repeat the same. When A is on, B could be on or off. Let's make this line a little bit bigger. And then when A is off, B could be either on or off. And this is how we have our 8 outputs. See how our outputs always start with a 0, so we're gonna have 8 outputs, but the numbers on the bottoms are gonna have only up to 7. So this is how we create, 6 and 7. So this is how we create an 3 inputs, 8 outputs decoder.